On a chilly February day in 1950, fate took a sinister turn near Brickhill, Buckinghamshire, as an ominous bang echoed through the air. The ill-fated aircraft met its demise, claiming the life of Squadron Leader Stuart Muller-Rowland. The investigation that ensued unearthed a haunting revelation. The true culprit was a flaw in its oxygen system, rendering the pilot helpless. As the plane plunged earthward, witnesses in Brickhill were gripped by the eerie symphony of swishing sounds, a macabre melody from the lone-winged aircraft spiraling out of control. The left wing's catastrophic failure, just above a humble garage, marked the beginning of the tragedy. The accident left a somber imprint on the desolate woods where the wreckage came to rest, brushing against an oak tree. Even 50 years later, remnants of the impact lingered for the world to find. In the aftermath of World War II, as the dust settled and nations embarked on a quest for technological supremacy, the British Air Ministry issued an air specification. The directive sought the development of an experimental single-engine, single-seat jet aircraft, all for testing the uncharted waters of tailless aircraft design. A response came from the de Havilland Aerospace Company, at the forefront of aircraft innovation. Under the stewardship of the visionary aerospace designer John Carver Meadows Frost, the wheels of progress were set in motion. Frost, later renowned for his work on the Avro Canada CF-100, delved into the challenge of creating an aircraft that would not only push the boundaries of speed, but also unravel the mysteries of tailless flight. Drawing inspiration from the annals of wartime engineering, Frost found himself captivated by the legacy of the Messerschmitt Me-163 Comet, a rocket-powered marvel from the German arsenal. This World War II interceptor, though not a game-changer for the Germans, had etched its place in history by shattering speed records, reaching an unparalleled 620 miles per hour in level flight. The Comet's tailless swept-wing configuration became a lodestar for Frost's ambitious endeavor. While the de Havilland Company had previously explored tailless designs for their Comet jet airliner, destined for commercial service, Frost opted to infuse elements of this experimentation into his new creation, the DH-108. In a subtle homage to the Comet, Frost melded German innovation with his own insights, paving the way for a unique aircraft that would push the envelope of aeronautical exploration. As Frost harnessed the legacy of the Me-163 and blended it with his cutting-edge research at de Havilland, the DH-108 began to take shape. In 1944, the forward fuselage of the de Havilland Vampire jet fighter became the canvas for a daring endeavor. With the existing de Havilland-built Goblin jet engine in its belly, a journey into the unknown began. Over the next 2 years, the engineers at de Havilland pressed on, assimilating 2 airframes from the English electric variant of the Vampire into their design. The cockpit and nose cone from these donor aircraft found a new home, seamlessly merging with the Goblin engine that steadfastly roared within. Frost and his team tirelessly refined the blueprint until the Swallow emerged, an entity distinct from its Vampire origins. The Swallow, though not christened as such by its creators, earned its moniker from the Air Ministry. A single-seat jet-powered research aircraft, it bore the weight of unraveling the mysteries of low and high-speed flight characteristics. In the bustling confines of de Havilland's Hatfield plant in England, 3 Swallow prototypes were meticulously crafted. Conceived under the watchful eye of Air Ministry specifications E-145 and E-1145, these aerial pioneers were destined to explore the uncharted realms of tailless, swept-wing aerodynamics. With a wingspan stretching 39 feet and a weight of approximately 8,940 pounds, the Swallow stood ready for its rendezvous with the skies. Its creators envisioned a beast capable of roaring through the heavens at a projected top speed of 677 miles per hour, covering a vast expanse of 730 miles in a single flight. On May 15, 1946, at the historic RAF Woodbridge in Suffolk, England, the first prototype, bearing the serial number TG-283, took to the skies for its maiden flight. Guiding this sleek aircraft through the air was none other than Geoffrey Roald de Havilland Jr., heir to the de Havilland legacy. Dedicated to the exploration of low-speed flight characteristics, TG-283 became a canvas for aerodynamic experimentation. The initial test revealed an unexpected challenge. The aircraft's speed lagged behind predictions, reaching a modest 280 miles per hour. Seeking solutions, a second test flight unfolded at an air show hosted by the Society of British Aerospace Companies, focused on unraveling the mysteries behind the speed discrepancies. Early wind tunnel assessment hinted at potential challenges during mid-air maneuvers and high-speed flights. Undeterred, the test pilots, cognizant of these predictions, adjusted their flying techniques to navigate potential issues. Determined to enhance the aircraft's performance, de Havilland designers set out to address these concerns. A novel landing gear was introduced to alleviate fuselage constraints, paving the way for further improvements. As the DH-108 project gained momentum, the second prototype, TG-306, emerged with a refined design. Taking flight on July 24, 1946, this experimental aircraft was destined for high-speed trials. With a 45-degree swept wing, modified leading-edge slats, and the installation of a potent de Havilland Goblin 3 engine, TG-306 showcased a leap forward in aircraft innovation. Swept wings, borrowed from a Handley Page aircraft design, and a new Goblin turbojet unit promised enhanced performance. The meticulous redesign extended beyond the wings as the pilot's seat was lowered, the canopy streamlined, and the nose reshaped. Armed with these modifications, TG-306 entered proving flights with great promise. Yet, tragedy loomed on the horizon, casting a shadow over the ambitious project. As the second DH-108 embarked on its crucial testing runs, tragedy struck on September 27, 1946. Hovering over Egypt Bay in the Thames estuary, the aircraft, piloted by the son of the company's founder, experienced a heart-wrenching breakup at a perilous high speed. Diving from an altitude of 10,000 feet at Mach 0.9, the jet succumbed to a catastrophic structural failure, sealing the fate of the daring pilot. The crash sent shockwaves through the aviation community, claiming the life of Jeffrey de Havilland Jr. His remains were recovered from the Thames estuary 10 days later. Investigative efforts unveiled a grim narrative. The violent and uncontrollable movements of the jet, induced by a stall in the jet engine, led to a fatal crack in the main wing spar. Undeterred by the somber turn of events, the indomitable spirit of innovation pressed on. Unyielding in the face of adversity, the aviation pioneers forged ahead with a third and final prototype, bearing the serial number VW120. This variant bore distinctive features, most notably a streamlined nose and cockpit canopy. Assembled at the Hatfield plant, the third prototype, rooted in the updated Vampire design, retained the trusty Goblin engine, now upgraded to the powerful Goblin 4. Generating a thrust of up to 16.67 kilonewtons, this powerhouse could enable the DH-108 to break the sound barrier. The streamlined nose and fuselage, reinforced structure, and a more compact cockpit aimed at enhancing aerodynamic qualities marked a bold departure from its ill-fated predecessor. Taking to the skies in July 1947, under the command of the seasoned World War II ace John Cunningham, the third prototype embarked on its maiden flight. Aviation pioneers set their sights on pushing the boundaries of speed and breaking the elusive sound barrier. In 1948, the de Havilland DH-108 emerged as a contender for such a feat. Designed with the goal of shattering airspeed records, this aircraft was meticulously prepared for a historic attempt in April of that year. On April 12, 1948, under the skillful command of de Havilland Chief Test Pilot John Derry, the DH-108 achieved a monumental milestone by setting a world speed record for a 100-kilometer closed-circuit flight at an astonishing 605.23 miles per hour. On September 6, 1948, Derry entered a shallow dive of 10,000 feet on the DH-108 and was believed to have crossed Mach 1. Despite its record-breaking successes, the DH-108 earned a dubious reputation among test pilots. The aircraft, while demonstrating stability in conventional flight, exhibited a disconcerting tendency to violently shake during high-speed maneuvers or dives, posing a severe threat to the pilot's safety. Undeterred by safety concerns, the DH-108 made appearances at prestigious events. In 1949, it graced the SBAC Farnborough Air Show before being handed over to the Royal Aircraft Establishment at Farnborough. Test pilots continued to achieve notable milestones with the DH-108, securing third place in the Society of British Aircraft Constructors Challenge Trophy Air Race and showcasing it once again at the Farnborough Air Show in the same year. The British Ministry of Supply, responsible for providing resources to the armed forces, took custody of the airframe in its quest for further tests and speed research. Then, the story of the DH-108 took a somber turn as tragedy struck again on February 15, 1950. RAE test pilot Squadron Leader Stuart Muller-Rowland took the helm of DH-108 prototype VW-120 at a Berkshire airfield. During the flight, one of the DH-108's wings separated, propelling the aircraft into an uncontrollable dive that ended in catastrophic disintegration. The subsequent report determined that violent movements of the cockpit before the crash had been enough to claim the life of the pilot. The final chapter in the DH-108 saga unfolded on May 1, 1950, at Hartley Whitney, where the first aircraft, bearing serial number TG-283, had met its tragic end. Squadron leader Eric Genders entered an inverted spin and bailed. However, altitude was not enough for his parachute to open on time. The quest for speed had exacted a toll, leaving behind a legacy of both triumph and tragedy. The year 1950 marked the demise of the original prototype, sealing the fate of the DH-108 project with a somber finality. All three airframes met a tragic end, shrouding the endeavor in a veil of sorrow and leaving an indelible mark in the aviation history books. Yet, despite its ill-fated reputation, the DH-108 etched its name in the skies with a series of groundbreaking achievements during its testing phase. A pioneer in its own right, it emerged as the first tailless and swept-wing aircraft crafted on British soil. Its unconventional design bestowed upon it the capability to attain speeds that eluded traditional aircraft configurations of its time. Amidst the tragedy, the DH-108 left behind a legacy that transcended its own misfortune. The invaluable data and insights gleaned from its trials became building blocks for the triumphs that followed. The baton was passed to the successful de Havilland DH-110C Vixen, a design that would go on to see mass production and serve prominently in the ranks of the Royal Navy. In the wake of destruction, the DH-108 spirit endured in the DNA of its successor. The three experimental DH-108 aircraft, despite their ultimate fate, became instrumental in shaping the trajectory of modern jet aviation. With over 480 test flights, they stood as the very epitome of an era where progress was measured by the courage of those who dared to push the envelope. In the relentless pursuit of advancement, these aircraft became symbols of daring exploration, proving that the only way to validate a theory was to put it to the test, even in the face of the unknown.